Today, we're going to talk about a different topic, but one that we hope is going to be very valuable to you. And that's the topic of how to visualize data. To set the stage for it, let me remind you that a couple of lectures ago, we looked at examining orders of growth, complexity. And there the issue was worrying about if I write two different algorithms to solve the same problem, but they come from different classes, they're going to take different amounts of time. They're going to take different amounts of resources. And our focus was understanding those choices between a linear algorithm, a quadratic algorithm, and God help us, an exponential algorithm. We could look at that just looking at numbers. We could look at that looking at mathematical expressions. But we also chose to look at it by looking at graphs, using graphs to help us visualize what are the differences in cost between a quadratic or exponential algorithm and a linear or logarithmic algorithm. That use of graphs gave us an intuitive sense of the differences between those choices. That's valuable. We're going to come back to that. But it also let us do something else. And in particular, it was an example of leveraging an existing library, something that was provided to us and just using those procedures rather than writing procedures from scratch. That's also a handy tool, and it's something that modern computer scientists use a lot. In the old days, you might write everything yourself. Today, other people have done a lot of work for you. And so what we want to look at in this lecture is the idea of using existing libraries to help us examine algorithms, procedures, data, and help us think about how we want to write our own procedures building on top of those libraries. It turns out that Python provides, or most Python implementations provide a set of nice libraries for you. Could be libraries for graphing, could be libraries for numerical computation, could be libraries for stochastic computation, and many other things. And we're going to look at one example of that today to explore the idea of using existing library procedures to guide processing and exploration of data. The library we're going to use is called PyLab. Now, you've already seen how to import things into a computing environment. You just say import. Here I'm going to use a slightly different version of it. I'm going to import PyLab, but I'm going to say in particular, import PyLab as PLT, short for plot. That's going to allow me to reference any of those library procedures with their name, but preceded by PLT and dot. Just lets me distinguish in my own shorthand, this is a plotting function. I could have picked anything to do that. PLT seems like a nice choice. That gives me then access to a range of graphing or plotting procedures, and we're going to look at those in a second. In this lecture, I'm just going to look at some simple examples. There's lots of wonderful additional information available in documentation associated with PyLab. I encourage you to go look at that. And indeed, if you choose to take the second part of this course, you will see many other examples and details of these ideas. Here, we want to look at the idea of using a library and using plotting to help us think about what's our algorithm actually telling us. Let's start with a very basic function to do that. The most basic function in PyLab simply plots two lists taken as being the x and y values of some function. Other data structures are much more powerful, and you'll see some nice examples of that if you take the second part of the course. In particular, using something called an array lets you do some processing very straightforwardly. Here, we're just going to focus on lists. First, let's generate some data. So I'm going to create 5 little lists called my samples, my linear, my quadratic, my cubic, my exponential. And I've got a little for loop down here that's going to generate some samples for me. Now, if you look at this, I'm running with a range of I from 0 up to, but not equal to 30. And I'm generating simply samples of I and linear samples of I. That may seem a little redundant, but I want to separate out the x values, which are my samples, from a linear function over those x values, which is my linear. And you can see I'm computing quadratic, taking I squared. I'm computing cubic, taking I cubed. And I'm computing an exponential, taking 1.5 to the ith value. So I'm generating a set of lists, and I'm going to plot them in a second. Now, since I motivated this by talking about orders of growth, really I should have used a value like 2 for my exponentials. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and so on. Unfortunately, that grows so rapidly, it's really going to make it difficult to visualize. So I've taken a slightly smaller value of 1.5, but you could use any value in here. So this little for loop generates for me 5 lists. A list of the numbers from 0 up to 29, which are my x values. A list of linear functions of that, which again would be 0 up to 29. A list of the quadratics, the cubics, and the exponentials, all associated with that set of samples. I'm ready to start plotting. So to generate a plot, I'm going to use PLT because I imported PyLab into that name. And then I've overwritten it, but then the dot, and then a call to the function plot. It's the simplest possible function for doing our procedure for doing plotting. And I need to give it 2 lists, a list of the x values and a list of the corresponding y values. And here I'm just going to plot my samples, which are the x values, and the simplest of the y values, which I stored up in my linear. As I've said before, for now, the arguments are lists. They could be other structures. You'll see that if you take the second part of the course. Most important point is the lists need to be of the same length. They both need to be of length 30 in this case in order for this to work. There are 2 ways in which I could actually call this function, or at least in my version of Python. Your version may be slightly different, but I want to show you both of them because you have a choice. I could call the function in an IPython or interactive Python console, and that will generate a plot right inside of the console. I could also call the function in a Python console, and that's actually going to generate a separate window in which the plot is displayed. So let me show both of those working. If I go to my computer, I'm going to start off with just a Python console. And in this case, I'm going to plot 4 functions. It doesn't matter. I just want you to see what happens. And if I plot those on my computer, you will see that nothing has happened, but a separate window is shown up. And in that window, I have, in fact, 4 different graphs overlaid. We'll come back to that in a second. This is nice if you want to store things in a separate window. You want to save things away. You want to be able to actually play with different aspects of the window. I'll let you explore that yourself, but in fact, in this window version of things, you can adjust scales, you can adjust other aspects of the graph. It's one way to deal with it. The second way I can deal with it is to do it inside of an IPython or interactive Python console. And here, if I call this function, you will see that it actually embeds the graph, the plot, directly inside of that console. And I could do other things inside of here. This is convenient if I just want to visualize but not manipulate. Using the full console version is nice if I actually want to do the manipulation. So I've got 2 different ways of doing this, and from now on in this lecture, I'm just going to show you the results of doing the graphing using actually a Python console so that I'm generating a separate window. So to remind you then, to generate a plot, I'm just going to call plot, giving it a set of x values, a set of y values. As long as they're the same length list, I'm going to be able to graph them out. And let's look now what happens if I do that. The simplest plot would simply be to plot my samples against my linear. And not surprisingly, it gives me this nice straight line because each value was, in fact, the x value represented as a y value. Simple example, you see what happens when I call the plot. In the next section, we're going to turn to doing more interesting things with these plotting functions.